Hi there, my name is Amy Mead, and I am going to present the results of my demographic trends and population impact of forest fires in high probability areas in Missoula and Ravalli counties in Montana. Interestingly enough, we are literally loading the trailer right now, putting the cats in the car, and we are headed to Missoula County this afternoon. So, sorry this is late. But I hope you learn a little bit about my soon-to-be, at least temporary home. I'm going to shrink this here. Okay, so where are we going and why do we care? This is Missoula and Ravalli counties. It's in the southwest part of Montana, surrounded by Idaho. Here, also surrounded by forest, National Forest Service land. That's what all this green is here. Missoula, county seat right here. Hamilton is the county seat of Ravalli County. This is the Bitterroot Mountains over here, and the Bitterroot Selway National Forest, as well as Lolo Peak National Forest. It's about 150 miles from top to bottom and 60 miles this way. I believe the 60 miles is like right in here. So to give you an idea of what the area looks like, these are tiger line shapefiles that I transformed from the whatever the tiger line projection was, and it's now in the state plane Montana projection. So also, if you're familiar with Montana, this is Butte here. I-90 comes up like this. This is the road to Helena. This is Flathead Lake in the Flathead Reservation. This is 93, which is just a road that goes straight down the valley into Idaho. Sola, Idaho is here. And then this is Route 12. There's some housing and things like that all along this area. So, all right. This is just some general information about forest fires. I chose this project because last year forest fires were all over the news. And also where we go in Wyoming, we were there 2 days after a fire. It was a grasslands fire, but after a fire had taken, I can't remember, over 100,000 acres, I believe is what it was. Literally in overnight, it just went so fast. And things like that are very hard to get a hold of. So forest fires really kind of came into my life, I guess, last year as we were driving through it with all the smoke in Montana. It seemed like the whole state was on fire. So I was like, hey, let's do something with that. I would watch the updates with the maps, and I thought, wow, that's really cool. I want to do that. So this is just a general idea of 2017 compared to past years. So 2017 is here. This is 2017 in terms of numbers of acres burned and number of fires. And this is acres burned per fire. And you can actually see the statistics down in here. So out of the last 18 years, 2017 was the third most. 2015 was the highest. 2015 has another record down here. But in terms of acres burned per fire, it was the second most. 2017 was the second most. The average is 85.5. Last year, it was about 150. So with 9.7 million acres. In 2015, it was 10.1 million acres burned. So this area is important because, or at least to me, one, I'm interested in it. There was a huge forest fire there last year. It is surrounded by national forest land, and there's a lot of people in the wildland-urban interface. So what is that wildland-urban interface? It is basically where people interact with the wildlands or the forest or the grass fires, whatever it is. Those are all called wildlands. So in Missoula, there's a relatively high population. We'll see that here in a minute. At least high population by Western standards. And there's a lot of people who go out and recreate in the forest. They camp, they hike, they hunt, all of these different things. They drive there. And Forest Service roads and things like that. They also live there. There's Forest Service cabins you can buy. There's little housing developments and things like that in the forest themselves, campgrounds in the forest. So the cities themselves are very, very close to the forest. Okay, we've got this valley here there's a river in it called the Bitterroot River. There's Clark Fork River up in here. But you can see based on the scale here, there's not a whole lot of distance between cities and the wildland areas. All right, so what's the population in the area? This is a dot density map. One dot is 400 people. This whole huge area down here is one dot. This is all done by census block group. That's the smallest area that the data is published. The population for Missoula County, the northern one here, is 113,000. For Ravalli County, it's 41,000. And all of this is the 2016 American Fact Finder data, the survey data. An interesting note here, there are huge differences in terms of size in block groups. So we've got this one down here and these little tiny ones in here. And I don't know if that had an impact in the statistical analysis that I did, but there's just vast differences in terms of size. So with population, to give you an idea of how many people are in these different areas, remember that it's surrounded by national forest land, all in here. Idaho is on this side, but this is all national forest with a valley with a river in it. So this is Hamilton right here, high density population, or high-ish population, as we would expect. But notice that the high-ish population is still only 2,000 to 3,000 people. And then this up here, Missoula, this is 3,000 to 5,000 people in here. Again, not a whole lot going on down here. This is mostly forest area. This is Flathead Lake area on your way to Glacier. So there's not a lot of population there. And they are concentrated along the highways in those cities. So I use the GI star statistical analysis, and I use the inverse area option for distance. When I was selecting that, I read through all of the different options, and with inverse area, it said that areas farther away have less impact. Given the size of some of these blocks, I thought that was probably best. The only problem is, you know, this one here only has 2 neighbors. This one here has 3 neighbors. So there's not a whole lot of options in terms of statistical comparison because there's not a lot of neighbors for some of these areas. Obviously in Missoula there are. So, you know, does the huge size impact and lack of neighbors making it change or I guess have an impact in the statistics? Probably, but that's the area that we've got. So, cities have some hot spots and relatively high confidence areas, and we'll look at the Missoula area here more specifically just because it's hard to see at the scale. Oops, it was working on it. Okay, so here's Missoula. Again, high density here. This is the highway comes through here. We've got high density, high density, high density. Well, I'm sorry, not high density. A hot spot. So high density populations with neighbors that have high density, especially up in here. Not so many cold spots, at least in terms of population. All right, so now looking at housing values, we've got areas, again, very sparsely populated down here with relatively low housing costs, very sparsely populated up here with very high costs. That is very true. These areas here, if you notice, this is Hamilton, this is Missoula, this is no data. The areas just outside of the city, even though we're talking huge distances, just outside of the city have higher housing costs. So we see the same thing here with cities. You know, everybody wants to move to the, well, not everybody, but people want to move to the suburbs, and that's where the higher housing costs are for a postage-sized lot. Same is true here, just on a different scale. We've got the cities, but people don't want to necessarily live in the city. They want to live outside of the city, and in this case, in the forested areas, which is where that wildland-urban interface comes in. So, and please note that the dark green, like this up here, houses, the average housing cost is $300,000 to $430,000. The data itself showed number of, I think the highest was 2 million and above, and this area had like 10 of those. So it's a spendy place to live. All right, now if we look at housing values and population, again, sparsely populated, but very high cost. Sparsely populated, very high cost. This is surprising. It's more densely populated with high cost, but the highway runs through here and there's a lot of little towns along this way. So I think that increases the housing cost. There is another relatively major route, meaning it's paved, from the forest where houses are up to 90. So, you know, that's going to increase the housing or the density, but the housing costs are just outrageous in there. Even though there's, you know, not even 400 people in this one, we still have sort of high costs down in this area too. All right, so Missoula itself, total population, this is population, this is housing costs. We have densely populated areas, relatively low housing costs, sparsely populated, higher cost. People just don't want to be around other people. This is, again, no data here. Sparsely populated, high cost here. So everybody's trying to get away from those city centers, which is human nature. We tend to want our space, but also be connected. But at the same time, we want to pay a lot for those houses and for that opportunity to do that. So what are the connections, statistically speaking? We actually have some hot spots and some cold spots. So areas of high cost surrounded by high cost, areas of low cost surrounded by low cost. It's generally around the city center, also close to the Flathead Reservation. This is as you get up into here. So this is a cold spot, but just above it is actually a huge area of high cost. So we've got kind of just a big difference in terms of low here and high here, right next to each other. This one, again, sparsely populated, high cost, and these other census blocks around it are also high cost. So we do have some cold and hot spots in terms of housing value. So here are the results. As a few statistically significant areas, could it be because of the block size or the number of groups or the neighbors? It doesn't matter. Statistics tell us it is what it is. Some areas with very low population have high housing costs, which is expected. If you can afford to get out into the woods, good for you. But there comes a risk with that, as we'll see here in a minute. And then there are statistically significant housing values just outside the city. So it's even the mountain suburbs, if you will. Okay, so now on to the fire part of the project. This is the National Fire or Forest Service FSIM simulation program data. Basically, they ran the FSIM fire simulation over and over and over and over, and they calculated how many times each cell burned. It's a raster file. This is the burn probability, so if you multiply this by 100, it tells us that this is 0.01% of burning, all the way up to 12% possibility of burning. So the metadata states over and over and over that you need to use burn probability along with fire intensity level together to really get a good picture of what might happen. So this is the study area that we're looking at. A lot of high probability area here. The highest is 5.4113%. The lowest is obviously 0. The lowest is right along here in the valley itself. It's not, I don't know that there's many zeros, but this is right along the river, along the Bitterroot, so it's well hydrated down in there. The FSIM simulations were based on Landfire 2012 data. It doesn't include every aspect of burning, but does look at general weather patterns, vegetation, burn patterns, things like that. So this is that was burn intensity. This is fire intensity. And they do it by flame height. So we have less than 2 foot flames all the way up to greater than 12. Again, the metadata says over and over and over to use burn probability with fire intensity level. I keep calling it flame intensity level. Basically, high burn, high flame is what I looked at for this. You can see the 2 to 4 foot range, basically the whole valley, the whole study area has a high chance of 2 to 4 foot flames. There was no sense in looking at that because everybody has a possibility of that. The 4 to 6 foot flames is right around the cities themselves. You can think of this as maybe where there are people. There's some trees in there. Just because there's a lower level of fire or a flame intensity, that just means that it's not likely that a 4 to 6 foot flame would happen there. As we can see, you might have a higher flame in that area. So what I did again, high burn probability and high flame is what I looked at. So again, metadata. The metadata mentioned this over and over and over. I felt like I needed to mention it over and over and over. So what I did is I used burn probability with the fire intensity level. I made buffers of both of those and then found where the burn probability and FIL layers overlap and then determined what the population impact. So the challenging thing with this is that this is a raster, but it's not an integer raster. And in order to convert it to a polygon, you have to make it an integer raster. So there's lots of calculators for it. Lots of research went into how to do this. So what I did is I used the raster calculator to convert these cell values into integers. I multiplied by 1 million. That way I kept all of the decimal points or decimal places. And then I used the INT tool to convert those new values into actual integers. And then I finally created the raster to polygon. Every single cell has a value. The polygons aren't like elevation polygons like we've dealt with the flooding and things like that. It's not a smooth transition. There are pockets here and there, so they're just not pretty. You can't make a really nice flowing sort of polygon with it. And there's a huge number of data points, and my laptop was like the $300 version from Walmart. My computer freaked out, crashed. It was too much data. So I couldn't do everything that I wanted to with this because of lack of memory. So for the data, the highest value, again, for burn probability is 5.4%, and the mean is 1.06. Basically, on all of these, I took anything over the mean, so mean or higher, to mean high probability. So these are the areas with the pixels selected that are greater than the mean value. Okay, so burn probability of greater than 1%, basically. That's the areas that we're looking at. And then I made buffers from that. And again, remember, this is a 150 by 60 mile area, so 1, 2, and 3 miles look very tiny. 1, 2, and 3 mile buffers look really tiny. I chose 1, 2, and 3 miles because a fire, an ember from a fire, can travel a mile and still have enough heat to it that it can ignite another fire. So we're looking at the worst case scenario basically 3 times over. So let's say we have a fire, an ember travels a mile, ignites another one, travels another mile. We've got 2 miles and 3 miles. 3 miles is probably not likely going to happen, but it's a worst case scenario 3 times over. All right, so what's the impact for burn probability alone? Again, the metadata says that we should combine burn probability with fire intensity level. So the areas directly in contact with a greater than mean burn probability is about 23–25%. Inside the 1 mile buffer, we've got about 30% of the population. Within 2 miles, we have 40%, and within 3 miles, we have 60%, 61%. There are a total of 107 blocks, just to give you an idea of how many blocks are impacted here. Also, if you look at this, we have 65% or 65 blocks out of 107, and with that, we have 94,000 people out of the 150,000 people. So, just little interesting facts there. Now, if we combine burn probability and fire intensity level, we're looking at flames greater than 8 feet is what I did. So flames greater than 8 feet. The red areas have higher than the mean probability of a flame higher than 8 feet. That's a lot to say. Basically, a high probability of a big fire in terms of height. So this is most likely, these are most likely to have embers that will travel because they are such tall flames that the winds aloft can carry them farther. That's why I combined these two. So where do the high flame, the FIL 5 and 6, where do the greater than 8-foot flame areas come in contact with the high burn probability areas? This map shows that. This is actually purple. It's just underneath the buffers. So that's, I did a select by location, found all those areas, and then I found the census block groups underneath that that were impacted by these different areas. So here's the actual numbers. For areas that are just in contact with the fire intensity level 5, we've got 96% of the population. Within a mile, it's the same, 96% of the population. If we look at intensity level 6, it's smaller, about 80% of the population. But again, the metadata says use burn probability and fire intensity together to get a true idea of who might be impacted. So if we do that, we only have 27 blocks, 36,000 people, about a quarter of the population. So those are the areas that we would need to focus most on, which are these areas here. All right, so because there are so many humans in the wildland-urban interface, there's a lot of education that goes on out there. This came from an article on wildfiretoday.com. Home insurance companies are now considering whether they want to offer fire insurance if you're in a high probability area. So that's something to consider, that, you know, this kind of data can be used for that purpose. There's a tremendous amount of information on how homeowners can protect their houses in terms of, you know, not moving trees away 100 feet, having your grass mowed, having the firewood away from the home, don't burn on days that you shouldn't be burning, things like that. So there's a tremendous amount of education to try to save people's property. And ultimately, you know, it's a fact that people do live in the forest. They play, if you will, in the forest. They camp. And it's something that we need to consider and remember, that we are living in nature, and fires are a part of nature, whether they're naturally started or human started. So thanks so much. I need to go help pack now. I hope you've learned something, and best of luck in wherever life takes you. Thanks.